Hello everyone, welcome to my YouTube channel Physics with Sagar. This is Sagar M. Patil. I have cleared KSET examination last year, that was in 2025. I was the 8th highest marks scorer last year in physical science subject. So in today's video we will be discussing about KSET examination that will be held in October this year. How can you prepare for this examination and what will be a better strategy? Like if you are preparing from a long time, then just continue that pace and try to solve previous year questions for now, and just don't study new subjects or new topics from now. Whatever syllabus you have covered, practice those questions, be thorough with those theory part, and try to solve the previous year questions of rest of the topics which you have not studied. Okay, and for those who have not even studied any subject or have taken a long gap from your preparation, or you are the one who is going to give the exam for the first time without any preparation, for next 45 days the best idea for you or best approach for the examination will be just go through previous year papers, collect previous year papers and go through all the questions in it. See which are the topics from all the different subjects, that are 9 subjects in physical science. What are the important topics from each subject? Like for mathematical physics, for an example, matrices, differential equation, complex algebra, complex calculus, and vectors. These are some very important topics from which questions are repeatedly asked, and some particular type of questions are only asked. Okay, so better you just solve previous year papers. In this video we will be solving mathematical physics previous year questions of some of the topics, and in the other part of this will be the part 1 of mathematical physics, and again there will be a part 2 for this same, where we will be solving rest other questions, that is from probability, numerical analysis, then Fourier, Laplace, all those. Okay, so for now in this video we'll be doing matrices and all. So your KSET 2026 examination will be held on October 11th, and roughly you have 45 days left for your exam. So best is you solve previous year questions. So this is matrices. So the first question you can see is, it is from Hermitian matrix. So before jumping into the question, you should know what are Hermitian matrix. Okay, so Hermitian matrices or Hermitian matrix is a matrix whose dagger is equal to itself. If A is a matrix and you take its dagger, then you will get the matrix itself. So now what is this dagger? It is transpose plus complex conjugate. Okay, for example, if you have a matrix A that is 0, iota, minus iota, 0. Okay, so what will be its dagger? For dagger, what you have to do? First take its transpose. So A transpose will be what? Change the rows by its columns. So this row will be changed by this column. So 0 and iota, 0, iota, and minus iota, 0. So this is your A transpose. Now you have to take the complex conjugate. What is complex conjugate? A star. That means wherever there is a complex number, you have to replace it by its negative. That is 0, minus iota will be iota, iota will be minus iota, and this will be 0. So you can see that you first took the A dagger, A transpose, then you applied complex conjugate. So this is A dagger. Now A dagger is what? 0, iota, minus iota, 0, which is equals to A. That means A dagger is equals to A. So these kind of matrix are known as Hermitian matrix. Okay, and I think if you want, you can just pause the video and note it down. Here I want to also tell you about one more type of matrix, which is known as orthogonal matrix. Orthogonal matrix. What is an orthogonal matrix? A matrix where the transpose of the matrix is equals to its inverse. It is known as orthogonal matrix. What are symmetric matrix? It is double M. Symmetric matrix. Symmetric matrices are E transpose equals to A. Skew symmetric or anti-symmetric are what? E transpose is equals to negative of A. Likewise, anti-Hermitian is A dagger equals to minus of A. Okay, so these are some kind of matrices. Now we will see this question. Now this question mixes two topics. One is like a concept from quantum mechanics, that all the matrices or all the observables like physical quantities, momentum, energy, not energy, momentum, angular momentum, spin, then your position, all these kind of physical quantities which are related to real world are Hermitian matrices. Like in quantum mechanics, operator are represented or represented by a square matrix. Okay, operators in quantum mechanics are represented by a square matrix. What is a square matrix? It is any matrix in which its row is equals to its column. Okay, n cross n matrix. Okay, so the order in which n is equals to m, it is known as a square matrix. So all the square matrices, all the operators in quantum mechanics are represented by a square matrix. Okay, so operators for any physical observable are what? Hermitian. Okay, like for momentum operator, the matrix will be Hermitian. Okay, so here you can see the question is, any Hermitian 2 cross 2 matrix H can be expressed in terms of 2 cross 2 identity matrix I. What is an identity matrix? Where all the diagonal elements are unity and rest other terms are 0. So this is an identity matrix. So here they are talking about 2 cross 2 matrix, so it will be like this. Okay, so any Hermitian 2 cross 2 matrix H can be represented or expressed in terms of 2 cross 2 identity matrix and 3 poly sigma matrix. Now you will study quantum mechanics, there you will know that the spin angular momentum, which spin is a physical quantity, so spin angular momentum Sx, Xy, Sz are h cut by 2 sigma x, h cut by 2 sigma y and h cut by 2 sigma z, where sigma x, sigma y and sigma z are your polymatrices. Okay, so there is a value for sigma x, sigma y, sigma z. If I tell you now, it will be just an unnecessary information for now in mathematical physics. Sx, Xy, Z are polymatrices. Okay, so what are they telling? You can just write an 2 cross 2 Hermitian matrix in terms of this identity matrix and this polymatrices sigma y, sigma z and sigma z. Okay, like this. Here they have mentioned like this. You can write a Hermitian matrix, but in which case it will be an Hermitian? Okay, in which case it will be an Hermitian, that is, at what values of a0 and aj the matrix will be Hermitian. You can see that if I put any complex value to this, again its Hermitian will be, complex conjugate will be, if this sigma x, if I convert it a1 as my iota or minus iota sigma x, okay, if it is a dagger will be what? Iota sigma x, okay, because sigma x is a what? Hermitian matrix. But this minus iota, a complex number, will make it as plus iota, and a dagger will not be equals to a. That's why your a naught and ax, ay, az all should be purely real. Okay, so the correct answer here will be a naught, ax, ay, az all are real. So D is correct option. I think I have told a lot of information here. We'll just uh, gather everything. That Hermitian matrix is a matrix where a dagger is equals to a. What is dagger? Taking its complex conjugate plus transpose. Okay. Now in this question they have told that we can write a Hermitian matrix like this in terms of identity matrix and polysigma matrices. Polysigma matrices sigma x, sigma y, sigma z are Hermitian. For now, you just remember that sigma x, sigma y, sigma z are Hermitian. If I multiply any constant which is complex with it, okay, like if I multiply sigma x with iota and make a matrix, its a dagger will be what? It will be minus iota sigma x, because sigma x dagger is equals to sigma x. Okay, so taking complex conjugate and dagger of this sigma x will give you sigma x, but this iota will change it to minus iota, and this a dagger will not be equals to a, and the matrix will not be Hermitian. So to maintain that, you have to multiply any constant which is not complex, okay, or complex in case you can say it is a purely imaginary. Okay, so to make a Hermitian matrix in this type, you have to select a naught, ax, ay and az as real values. Okay, so moving ahead to the next question. So this is your next question. This is from eigenvalue and eigenfunction. So before that, I would like to tell you about eigenvalues. Okay, so what are eigenvalues? Whenever an operates on a function, like for example, if I have a matrix, okay, and I operate it on any function x, okay, and it gives back the function x with some constant, then this matrix is known as eigen function. What did we do? If we multiply or operate a matrix on a function and it gives back the function with some constant, then that matrix is known as eigenfunction or eigenvector, and the constant is known as eigenvalue. Okay, now how do you calculate this eigenvalue? To calculate the eigenvalue of a given matrix A, what you have to do, just subtract lambda I from it and take its determinant equals to 0. By solving a equation which you will get from this determinant, you will get the eigenvalues. If your matrix is 2 cross 2, then you will have 2 eigenvalues. Okay, and if you have a 3 cross 3 matrix, you will get a 3 eigenvalues. Okay, sorry for my handwriting. I am recording a video after a long time, so just excuse me with my handwriting. Okay, so what is an eigenfunction? A function, a matrix when multiplied to a or operated on a function, it gives back the function with some constant. Then that matrix is known as eigenfunction or an eigenvector. The constant which it gives back is known as eigenvalue. For a 2 cross 2 matrix, there will be 2 eigenvalues. For a 3 cross 3 matrix, there will be 3 matrix. For n cross n matrix, there will be, comment down the answer. Okay, now there are how do you calculate a matrix? Like I will give you a matrix 2 cross 2 matrix 1 2 0 1, and I will tell you to calculate the eigenvalues. How do you calculate? Just multiply this. Like what is the process? Determinant of a minus lambda I equals to 0. So what is your matrix A? 1 2 0 1 minus lambda into I. What is I? 1 0 1. This is identity matrix equals to 0, and you have to take the determinant of this. So it will be what? 1 2 0 1 minus lambda 0 0 lambda equals to 0. So this will be 1 minus lambda, this will be 2, 0 minus 0 will be again 0, and 1 minus lambda, 1 minus lambda, this equals to 0. What we will get from here solving this matrix eigenvalue, sorry, this determinant? It is 1 minus lambda square minus 0, okay, equals to 0. What will be next? It is 1 minus lambda square equals to 0, which is 1 minus lambda equals to 0. So you will get lambda equals to 1. But it is not just 1, it is square of this, so you will get 2. 1 comma 1 will be the matrix. Okay, so there are some important properties of eigenvalues you have to remember. So that was the process. First is sum of eigenvalues is equals to trace of that matrix. What is trace? If this is my matrix, then its trace will be sum of trace of A. Okay, trace of A will be equals to sum of diagonal elements. So for this matrix, what will be trace? Trace of A will be equals to 1 plus 1, that is 2. So in previous slide you can see that our eigenvalues were 1 and 1. So sum of eigenvalues will be lambda 1 plus lambda 2 will be what? 2. So trace is also 2. So this is proved. Sum of eigenvalues is equals to trace of A. Second, the product of eigenvalues is equals to determinant of A. Okay, so this will be your second property. Most of the eigenvalue and eigenfunction related questions will be solved from these two properties, that is trace of A and product of trace of A and determinant of A. Trace of A is equals to sum of eigenvalues, product of eigenvalues is equals to determinant of this. We can prove this second property. See, what is your determinant of A? Determinant of A will be equals to what? 1 minus 0. Okay, so it is 1. And you can see your two eigenvalues are what? Lambda 1 is 1, lambda 2 is also this. So lambda 1 into lambda 2 is what? 1 into 1, which is 1. Okay, so these are the properties. One more useful property is, if you have third property, if you have scalar matrix, upper triangular matrix, lower triangular matrix, then diagonal matrix, then for all these type of matrix, the eigenvalues ai, lambda I, if 3 cross 3 matrix, then there will be 3 matrices. So for these type of matrices, your eigenvalues will be diagonal elements. For example, if I take a 3 cross 3 matrix like 1 2 3 0 0 0 0 0 0, so for this matrix A, the eigenvalues lambda 1, lambda 2 and lambda 3 will be 1, 2 and 3. Okay, it is a diagonal matrix. That means only diagonal elements are non-zero, rest all elements are 0. Okay, scalar matrix is what? A matrix for which it is a diagonal matrix itself, where only diagonal elements will be non-zero and all the diagonal elements will be same, like scalar matrix. It is a 0 0 0 0 0 0. This kind of matrix is known as scalar matrix. What is upper triangular matrix? Upper triangular matrix is diagonal elements plus this upper triangular elements will be non-zero. Okay, and lower triangular matrix means diagonal plus lower triangular elements will be non-zero. For all these type of matrices, its diagonal elements are its eigenvalues. And the fourth property, one more property, if you have a matrix such that, example I will take 1 2 3. Okay, next row will be some scalar multiple of the first row. That is, if I multiply it by 2, you get 1 into 2 2, 2 into 2 4, 3 into 2 6. And again the third element is, third row is also some scalar multiple, that is by 3. Okay, so 3 6 9. Or this matrix also 1 1 1 1 1 1 1. It is a scalar multiple of 1 of the first row. Okay, so these kind of matrix, lambda I is, that means lambda 1 lambda 2 lambda 3, one of the eigenvalue will be trace of A, one eigenvalue, and rest will be 0. Okay, so for this the eigenvalues will be, lambda I will be what? 1 plus 4 5, 5 plus 4 is 5 plus 9 is 9, 5 plus 9 is 14, 14 comma 0 comma 0. So this is your eigenvalues. Here the eigenvalues are 3 0 0. So this is all about eigenvalue and eigenfunction in brief. There is a lot more, but this much will help you a lot. So let's start solving the questions. So the question is, one of the eigenvalues of matrix, okay, I have to tell you some more properties. If matrix A11, A12, A21, A22 has eigenvalues as lambda 1 and lambda 2, okay, and I take any function of this matrix f of A, okay, so the lambdas will be, the eigenvalues for this matrix will be f of lambda, that's it, lambda I. For example, if A is some matrix and I take another f of A as e to the power A, okay, and this has eigenvalue lambda 1 and lambda 2, so the eigenvalues for this f of a will be e to the power lambda 1, e to the power lambda 2. This is a property. Okay. So see, one of the eigenvalues of a matrix e to the power a is, so for a matrix e to the power a, as you can see, A is a 3 cross 3 matrix, so e to the power A will be also a 3 cross 3 matrix. Okay, so for this they have given one of the eigenvalue is e to the power alpha. Here you can see e to the power alpha. I hope this is visible to you. Okay, so one of the eigenvalues e to the power alpha. Next two eigenvalues we don't know, where A is this matrix. The product of the other two eigenvalues is, so first you have to calculate the eigenvalues of this matrix. So this matrix is what? Alpha 0 0 0 0 minus alpha iota 0 iota alpha and 0. So how to calculate the eigenvalues? Just a minus lambda I. Okay, so what will you get from here? Alpha minus lambda 0 0 0 0 minus lambda. Okay, and the third element here will be minus iota alpha. Next 0 iota alpha as it is, and 0 minus lambda equals to 0. What will you get? A minus lambda into, this will be minus lambda into minus lambda will be lambda square, and this one minus is already here, and this will be minus iota square alpha square equals to 0, because next two terms are 0 0, that will contribute nothing. So a minus lambda into lambda square, minus minus 1, minus into minus will be plus, but iota square is what? Iota is under root minus 1, so iota square is minus 1, so you'll get lambda square equals to alpha square equal to 0. So from here you get lambda equals to alpha as 1 and alpha equals to plus minus alpha as your other two roots. Okay, so your lambda I for this A matrix are plus alpha and minus alpha. So using this property, if A matrix has lambda 1 and lambda 2 as its eigenvalues, f of A will have e to the power lambda 1, e to the power lambda 2 as its eigenvalues. So what will be the eigenvalues for e to the power A? E to the power A will have e to the power alpha, e to the power alpha, e to the power minus alpha. Okay, I'll erase this part. Okay, so they have given that one of its eigenvalues e to the power alpha. What will be the product of other two? Okay, so you know e to the power alpha is this, the other two is what? E to the power alpha and e to the power minus alpha. So e to the power alpha into e to the power minus alpha, what do you get? E to the power alpha minus alpha, that is e to the power 0, which is equals to 1. So option A is your correct answer. Okay, there is one more method to solve this problem. Let's see how do we solve by another method. Okay, so lambda 1 lambda 2 lambda 3, that is, if you are very used to this type then you can solve, but for now this is the method you solve by this method only, because I was telling about this formula that you use trace of A and determinant of that. From that also you can solve the question, but for now let it be. We'll move to the next question. What is the next question? Given the matrix A equals to this, a matrix A equals to 1 by 3 into this is given. We can write this matrix as like this also, 1 by 3, 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 1 by 3 and 1 by 3. Okay, what is the determinant of e to the power a? Okay, so can you tell me what will be the eigenvalue of this matrix? You can see this is the scalar this row is scalar multiple of this, again this is the scalar multiple of this. Okay, all three rows in this matrix are scalar multiple of each other. For that I have told you one property, that if it is like this, then one of its eigenvalue will be equals to what? Sum of the trace, and the other two will be 0. Okay, so in this question one of the eigenvalue of this will be sum of this diagonal element, that is trace of a. What is that? 1 by 3 plus 1 by 3 plus 1 by 3. What you will get? 1. The rest 2 will be 0. Okay, so they have asked for e to the power a. If e to the power a is a matrix, then the eigenvalues will be what? E, 0 and 0. Sorry, not 0, 0. E to the power 1, e to the power 0 and e to the power 0. That means it will be e, 1, 1. So these will be the eigenvalues of e to the power a. And I have told you one more property of eigenvalue, that the product of eigenvalues is equals to determinant of a. So they have asked you the determinant of e to the power a. What did you do? Calculated the eigenvalues of a, then wrote the eigenvalues of e to the power a. Now you know the eigenvalues of e to the power a. If you want to get the determinant of e to the power a, what you will do? The product of eigenvalues. What is the product of eigenvalues? E into 1 into 1. It is e. So option B is correct. Okay, if you don't remember this property, you can calculate the eigenvalues by applying a minus lambda I equals to 0. From this you will get 3 eigenvalues. Then if you have for a, then you can write eigenvalues or any function of a. From there you can calculate trace of a or determinant of a according to the question. Next question. I hope this question is visible to you. The eigenvalues of a 3 cross 3 matrix A are, you have given a matrix A for which the eigenvalues are 1, 2 and 3. Okay, if E is a 3 cross 3 identity matrix, E is a 3 cross 3 identity matrix. Okay, then which of the following statement is correct? So you know eigenvalue, so check for these two options first. Because KSET is an MCQ type, only one answer will be correct. So elimination method is the best approach to solve this kind of questions. If you know eigenvalues, what will be trace? Trace of A will be what? Sum of eigenvalues. 1 plus 2 plus 3 is 6. And determinant of A will be what? Product of eigenvalues. That is 3 into 2, it is 6. 3 into 2 into 1. Okay. So neither of these two is correct. So these two options are eliminated. Now this question will be solved by a theorem called as Cayley-Hamilton theorem. What is that? There is a characteristic equation written for any matrix. For 2 cross 2 matrix, A11, A12, A21, A22. For this, characteristic equation is written like this: a square minus trace of a plus determinant of A equals to 0 for 2 cross 2, and for 3 cross 3 it is written as A cube minus trace of A into A square plus A into sum of minors of diagonal elements minus determinant of A equals to 0. Like this you can write. Okay, this is the characteristic equation, but what Cayley-Hamilton theorems say that you can write it similarly for the eigenvalues also. That is lambda square minus trace of A plus trace of A into A. Okay, trace of A, here it will get lambda. So this will be lambda plus determinant of A equals to 0. Okay, so how will you solve this question now? You just write the characteristic equation for this given matrix. Option B and C are eliminated. Now first convert this equation. How will you convert this? Multiply this A inverse on this, like A inverse will be what? 1 by A. Okay, so if you multiply this equation this side, you will get 1 equals to 1 by 6 into A cube minus A square plus 11 by 6 E into A. E into A will be again A because E is an identity matrix. Okay, and just take the LCM 6. So what we will get? A cube minus 6A square plus 11A equals to 6. Take that 6 on the left hand side, it will be minus 6 equals to 0. So according to characteristics equation, what was that? A cube minus trace of A into A square plus sum of minors of diagonal elements into A minus determinant of A equals to 0. So what is the trace of this equation given matrix? The matrix is not given, the eigenvalues are given, so trace is 6 and determinant is 6, which we calculated earlier in this. Okay, so just keep that in the equation. Since the matrix is not given, you cannot calculate the sum of minors of the diagonal, but you know trace of A and determinant of A, just put that. So A cube, what is trace of A? It is 6A square plus, leave this part, A minus 6 determinant of A equals to 0. So if you compare these two equations, you can see that the equation is almost same. So option A is correct. Okay, moving ahead. This is question from KSET 2024. A real orthogonal 2 cross 2 matrix is given by A equals to A, B, C, D. What will be its A inverse? It is a very easy question. Okay, so if 2 cross 2 matrix is given, okay, then to calculate its A inverse, what you have to just do is divide its determinant, and if the matrix is like this, A, B, C, D, okay, then just replace these two elements, diagonal elements, that by each other. This D will come here, A will come here, and these two will remain at this position. Just put a negative sign. So this will be A inverse. But here they have given orthogonal matrix, and for orthogonal matrix its determinant is +1 or -1. For any orthogonal matrix, its determinant is +1 or -1. So A inverse can be also written for orthogonal matrix, which is given here A, B, C, D. You can write it as D, B, C, A. If you take this minus outside and just take the determinant as -1, this can also be an answer. So check where this option is there. D, B, C, A. So option 3 is correct. Okay, so here we finish our matrix part. Let's move to complex algebra. So complex algebra and calculus, what do you see here mostly is there will be a integral given to you and they will ask you the question, what will be the value of that integral. Okay, so it is solved by a topic known as Cauchy-Riemann integral. I am really sorry, Riemann का spelling याद नहीं आ रहा. So Cauchy-Riemann integral, this is the topic from which you solve those questions. I am really sorry. Okay, the question, the Cauchy-Riemann integral, what it suggests that for any function f of z, okay, f of z dz, closed integral, its value will be equals to plus minus 2 pi iota into sum of residues. We have studied this complex algebra, Cauchy-Riemann integral, everything in your BScs and MScs. So I don't think many will have problem regarding this. But when we have to take plus and minus, if the contour is given as clockwise, then you have to take minus sign. If it is anti-clockwise, okay, so that time you have to take plus. Okay, so now how to calculate these residues, everything we will discuss. For residues, first of all you should know what is known as poles. For poles you should know what are singular points. Okay, so singular points, okay, singular points are those points at which your f of z is not analytic. What do you mean by analytic function? That means your f of z will not be analytic function at singular points. What is analytic function? Analytic function is a function which is differentiable at that point, given point. It is continuous at that point and it is definite. That means it has some particular value. Okay, so if it is not differentiable, continuous and defined, then that is known as not analytic function. Okay, so for those kind of points at which the f of z, your given complex function, is not analytic, are known as singular points. Okay, there are nature of singularities also. These things are also asked, nature of singularities. They will give you f of z and they will ask the nature of singularity. Okay, now to know nature of singularity, you should know what is Lorentz series first of all. Okay, so Lorentz series, you have studied power series in which there are Taylor series, Maclaurin series and Lorentz series. Taylor series I hope everyone knows. First I will write Taylor series. Wait. Taylor series is what? f of z is equals to summation f of z f to the power nz at z equals to z naught. That means you expand that function about some particular point. That point is known as z naught. Okay, so f to the power nz, this z minus z naught to the power n upon n factorial. I hope. Upon n factorial. Just check this. No, there is no n factorial. N factorial. So this is Taylor series expansion. Okay, and what is Lorentz series expansion? So f of z is equals to, here n limit is from n equals to 0 to infinity. Here also n equals to 0 to infinity an z minus z naught to the power n plus n equals to 1 to infinity. See, here n equals to 0 to infinity, here n equals to 1 to infinity bn upon z minus z naught to the power n. So you can see that in Lorentz series there are some negative powers of z. Okay, so if you have negative powers of complex function number, then it is for Lorentz series. That means you expand about singular points in Lorentz series, but in Taylor series and Maclaurin series you don't expand your function at singular points. Singular points are those at which analytic the function is not analytic. Okay, so you expand only at singular like both at singular and non-singular points in Lorentz series. That means you will have some negative powers of your complex number, that is z. Okay, let's move. Now nature of singularity. If there are zero terms in, you know what is this part known as in Lorentz series? This part is known as analytic part. Okay, and this part, it is known as principal part. Principal part. Okay, so this is known as principal part. If there are zero terms in principal part, then it is known as removable singularity. Okay, if there are finite terms, that means the series expansion of negative powers of z ends at some particular point, then it is known as non-essential singularity. If there are infinite terms in principal part, then it is known as essential singularity. Okay, now how do you come to know about poles? Okay, then we will study how to calculate residue, okay, at the end. So what are pole? If we have a function like this, 1 upon z square z square plus 1 dz. Okay, so this part we will put to 0. Whatever points you will get, by solving this, will be your singular point. So for this function f of z equals to 1 upon z square plus 1, z equals to plus minus iota is your singular points. There are two singular points for this. Okay, that means at these 2 points your function is not analytic. Okay, and how to calculate residues? If there is simple pole. Okay, so this function you can write it as z plus iota into z minus iota. So plus iota and minus iota both are simple pole. Okay, so how to calculate how to write that residues, we'll see afterwards. Now if the function is like this, z square dz, so if you put z square equals to 0, we'll get nothing, two zeros. Okay, so z square equals to 0, not 2 zeros, there is nothing further. So z equals to 0 is a pole of order 2. Order 2. Okay, I don't have many examples to show you here, but you can understand from here. Pole order, everything you have studied before. So we'll write some formulas for this if simple pole is there. Okay, then residue at z equals to z naught, any pole. Okay, it will be limit z tends to z naught, z minus z naught f of z. This is one formula. Second, if your f of z is like this, phi of z upon psi of z, that means in numerator and denominator both you have a algebraic function of complex number, then you will calculate the residue at z equals to z naught as for pole of order 1, simple pole. Okay, this is all for simple pole. So residue here will be limit z tends to z naught phi of z upon psi dash, that means first derivative of the denominator. This will be your residue. Third, for pole of order n. Okay, so residue at z equals to z naught will be equals to limit z tends to z naught 1 upon n minus 1 factorial dn minus 1 by d zn minus 1 of z minus z naught to the power n f of z. So this will be the formula. Okay, so let's start the question. Or else you can also see that if you expand f of z, okay, when you expand f of z and the coefficient of z minus z naught, if it is order of pole of order 1, that is it is a simple pole, then the coefficient of z minus z naught, when you will expand the function, when the coefficient of this term z minus z naught will be the residue. Okay, this is a trick, but it is only applicable when you will be able to expand that function. So a easier thing is just solve that by removing the pole. So your f of z, here you can see 1 by z, so z equals to 0 will be your what? Pole of order 1, simple pole. Okay, so calculating residue here, will be what? Residue at z equals to z0 will be equals to limit. Here z0 is 0. Okay, because this integral you can write like this, dz upon z minus 0. Okay, so from here you will get z equals to 0 as your pole of order 1, that is simple pole. Okay, so z minus z0, z tends to 0. Here you write z minus z0. See, z minus z0. So z minus z0 will be z minus 0 into f of z. What is f of z? F of z here is 1 upon z. So 1 upon z. So this cancels out and your residue as z minus z0 is equals to 1. Now in this question they have given the integration is done in clockwise path. So this value dz by z will be equals to what? Minus 2 pi I, because I have told you in Cauchy-Riemann integral we, I think I have erased it. In Cauchy-Riemann integral we use minus sign when clockwise path is used. If anti-clockwise path is there, we use plus. Okay, so minus 2 pi I into sum of residue. Since there is only one pole, we will get only one residue, that is 1. So the answer is minus 2 pi iota. Okay, so option B is correct. Next, the question is asked that if v of x comma y is 2xy plus 3 and f of z is something like this. F of z is u of xy plus iota v of x comma y is analytic, and further f of z is this, then the function u x comma y. So you have already studied that in your BSc is that f of z, a complex function, can be written as real part plus imaginary part. And if it is analytic, you have studied CR equations. Okay, what is CR equation? Del u by del x is equals to del v by del y, and another equation is del u by del y is equals to minus del v by del x. Okay, these are two equations. So solving this, you can calculate u of x. How? You are already given v of x comma y. So when you solve v of x, this equation, just del v by del y, what you will get? Del u by del x will be differentiation of del v by del y. V is 2xy plus 3. So differentiation of v with respect to y will be 2x. Okay, so integrating this, you will get 2x square by x plus c. Sorry, 2x square upon 2 plus c. Okay, see, del u will be equals to integration 2x dx. So this will be 2x square upon 2 into c. So 2 cancels out, x square plus c. And solving by from this equation, you have to apply for both. So del u by del y will be equals to minus del v by del x. Differentiating this equation with respect to x, we will get minus 2y plus c. So what we will get? Minus, sorry, not c, c will not come here now. So you will get minus 2 y square by 2 plus c. So you will get x square, sorry, minus y square plus c, u equals. So finally you write u as, you have to write both the terms, like here x square, from here minus y square, and whichever terms which repeats, you have to write it only once. Like if here also it comes x square, only x square will be there. Okay, so this will be your u. but they have given some condition that f of z equals to 0, you will get 2 plus 3 iota. Okay, so if you put this u in this equation, what will be your f of z? Wait, so f of z will be equals to what? You already had 2xy plus 3 equals to, sorry, that was v, na? So your u is what? X square minus y square plus c, plus v will be what? 2xy plus 3. Okay, so this is your f of z now, but they have given f of z equals to 0 is 2 plus iota 3. So you have to put x equals to 0 and y equals to 0, then you will get this equation. So by comparing this two, we will get what is c. Okay, x equals to 0 and y equals to 0. Why? Because z equals to 0 is given. Okay, so at z equals to 0, that means you put x equals to 0 and y equals to 0. So 0 0 will be, this will be 0, this will be 0. C plus, here x y 0 means 3 iota. So comparing these two equations, you can see that your c is equals to 2. Okay, so your u x comma y will be what? X square minus y square plus 2. So check in which equation, in which option it is given as that x square minus y square plus 2. No, this is not. This is also not. This is also not. So option C. But solving this question like this in examination will be a lengthy process. Okay. So what I suggest is just go through the options. You can see that they told that f of z will be u plus iv. Okay. And they have given f of z equals to 0 for 2 plus iota 3 iota. This part will be equals to 3 iota at, because v is equals to what? 2xy plus 3, and iota v will be 3 iota when xy equals to 0. So 3 iota you will get. You have to get this term as 2 for u. Whatever option you will get, u equals to 2 you will get whenever x and y will be 0. Okay, x and y will be 0, then you will get u as 2. So just check for which option you will get u equals to 2 at x equals to 0 and y equals to 0. So in this equation you will get 0. In this also you will get 0. Here also you will get 0. Only here you will get 2. So this condition f of z equals to 0 equals to 2 plus iota 3 will be only satisfied when option 3 will be your u. So solving the questions by options will save your time. Okay, let's move to the next question. Now this question is a difficult one, I would say, for those who have not studied or prepared for a long time. In exam, I will suggest you to skip this kind of questions, but now you can see. For these kind of questions where minus infinity to infinity cos ax is given upon x square plus a square dx. For this kind of equation, what you have to do is, and a is positive. Okay, what you have to do is, first of all, write this equation in terms of complex part values, like cos az upon z square plus a square dz. Now you know what is e to the power iota m theta. This is cos m theta plus iota sin m theta. Okay. So you can see cos az. What is this? It is the real part of e to the power iota az. Okay. And this. So you can write this equation as real part of minus e to the power infinity to infinity e to the power iota az upon z square plus a square dz. Okay. And Cauchy-Riemann integral is for closed integral. That means for a circular path. Okay. For this kind of thing. But here the limit is given from minus infinity to infinity. So in this case the integral value minus infinity to infinity f of z dz, it is pi iota into sum of residues of poles on real axis, that is this x axis, minus x2 plus x. Okay, plus 2 pi iota into sum of residues of poles in upper argand. Okay, that means upper part, only upper part, not lower part. You not have to take the poles which are in lower part of the y axis. Okay, this upper part you have to calculate. So this will be the formula. Next, what you have to do, you have written the written the integral in this type. Just write down this formula. Okay, you have to convert this integral in this type. Now remove the calculate the poles. What is this? Z square plus a square equals to 0. So z square will be equals to what? Minus a square. That will be z equals to plus minus iota a. But minus iota a is in lower argand. That means minus y axis. Okay, negative of y axis. So you have to take only z equals to plus iota a as your pole. So then pole, then residue, then you can solve further. Let's solve this question. Let's take the question. Okay, you have integration minus infinity to infinity cos x upon x square plus a square dx. You have to first convert it in z. Okay, minus infinity to infinity cos z upon z square plus a square dz. Okay, now you have to write it as real part of this integral, whatever you get the value, e to the power iota az upon, not a, because a is 1 here, so iota z upon z square plus a square dz. Now it is your normal complex function like this, phi of z upon psi of z, f of z equals to, it is in this type because in numerator also you have a function of z, denominator also. So first calculate the poles. We have already calculated the poles for this, so it will be plus iota a, minus iota a will not be considered, and since it is on y axis, minus iota a, so you will multiply by 2 pi I. Okay, so residue will be at z equals to iota a, which will be equals to what? Limit z tends to iota a, and for this type of function you can write it as e to the power iota z upon differentiation of this. What we will get? Here it is a square. Okay, so differentiation of this, a is a constant, so it will be 2z. Okay, simple. So just write it down. What we have to do? Substitute the value of z equals to iota a in this equation. What you will get? E to the power iota into iota a upon 2 iota a. Okay, so this is residue. What you will get? E to the power minus a upon 2 iota a. So integration will be real part, and this value will be what? 2 pi I into sum of residue. Only one residue is there, e to the power minus iota a upon 2 iota a. Iota iota cancels out, 2 cancels out. Since everything is real only, so you will get pi into e to the power minus a upon a. So check which option is there. Pi by a, e to the power minus a. So this is not the correct option. A by pi is not the correct option. A by pi is not the correct option. Option D is the correct answer. Okay. So here, next question. I hope you understood. If you have not understood, just go back, and if you have any doubts, you can contact to my number. It is 9611250861. The video is lengthy, so I will wind up it at this question, and the further questions will be continued in next part. The value of the integral, this will be the last question of this part. The value of the integral 1 upon 2 pi iota close integral c z to the power m minus n minus 1 dz. What will be the value of this when where m and n are integers, positive integers, okay? And c is a circle centered at origin. Okay, we have a contour. C is what? Contour, which is centered at origin 0, 0. Okay, so what will be the value? Its value will be 0? No, because it has some negative power of c minus 1. If both are in 0, then it will have some value. Okay, so at m equals to n, then only it will be no, at m equals to n, what will be the value? It will not be 0, because it will be 1 upon 2 pi iota if m equals to n. Okay, so what will be that? M equals to n means it will be 0, 1 upon z. Z to the power minus 1 is, so this value will be 1. Okay, so it will be non-zero if m equals to n. Okay, and it will never be this m minus n, because it has to be the coefficient. Okay, it will be equals to 1 only when m is equals to n. But this option C satisfy both. It will be 0 if m is not equals to n. If m is not equals to n, that means the powers of z will be positive always. Okay, since the power will be always positive, then there will be no negative terms of z. That means negative powers means 1 upon z plus 1 upon z square. This type of terms will not be there if m is not equals to n. Okay, so it will be 0. If no negative points, negative powers, that means there is no pole. If no pole, then no residue. Okay, so that's why it is 0 when m equals to n, and 1 if m equals to n. This we have proved. Okay, so option C is correct. If you have any doubt, you can reach out to me by contact number 9611250861. In next part, we will solve some questions related to 1 or 2 questions are left from complex also, and then we will solve vectors. Okay, Thank you so much for watching the video, and I hope you prepare well for your exams, and this video might have helped you in any sense. The video became very lengthy because I explained the theory also, because that is necessary. Just knowing the solution of that particular question will not help you in the examination. This will take your half an hour, one hour something. I don't know how long this video has been now. Okay, so it will take some time, but it will be very useful for your exam, because you will be knowing the concept behind that question also. I hope you enjoyed the video. Please reach out if you have any doubts. Thank you so much. Have a nice day.